In this example, we're given a couple of functions, f of x and g of x, and this time we're going to do the composition function. When you read this, you would read it as f of g of x. So each time you get to a left parenthesis, you basically say the word of. Do the same thing here with regular functions. This is f of x, this is g of x, this is f of g of x. This can be written a couple of different ways. So it is the same as f of g of x written this way. Here, where normally we would have an addition or subtraction symbol, we have a tiny little open circle about the size of a degree sign. So those are the same thing, just written two different ways. When you go through and you calculate a composition function, what you do is you take the second function. So from left to right, f is here listed first and g is listed second. We're going to take the second function and we take that function and we put that in place of all of the variables in the first function. So I'm going to take g of x, which is a 3x minus 5, and I'm going to take that 3x minus 5 and I'm going to substitute that in for each one of the variables that are in function f. So originally function f was x squared plus 1. When I do this problem with the composition function, I'm going to be replacing that x with the other function. So I'm going to put in parentheses here where the x was, so that'll be parentheses squared plus 1, so that's what I have there. There's function f, but written so that there are parentheses where the variable was. And now in the place of that variable, I'm going to be putting in a 3x minus 5. To finish this composition function up, I just need to get rid of the parentheses there and then combine like terms. If you haven't memorized the binomial squared formula, remember that you need to think of this 3x minus 5 squared like a 3x minus 5 times another 3x minus 5. If you FOIL that out, you would get 9x squared minus 15x minus another 15x plus 25, which would give you 9x squared minus 30x plus 25. If you've memorized the binomial square formula, then you could do that step in your head. Otherwise, just a little work off to the side lets us know that this 3x minus 5 in parentheses squared would give us a 9x squared minus 30x plus 25. And then out on the end, we would still have that plus 1. So if we combine our like terms after that step, we would have 9x squared minus 30x plus 26 for our final answer for that composition function. Let's practice that one more time, but this time let's do the composition function the other direction. Let's do g of f of x. So from up above, let me just copy down what f of x and g of x are equal to again so we can see all of this without having to go up to the directions. So here's what f of x and g of x were originally. And what we want to do in this case is take f of x, so that's this, and we are going to put that in place of all of the variables in g of x. So where this x is here, we're going to put in function f. So the original function g was 3x minus 5. But now in place of that x, we're going to put in an x squared plus 1. So that's what our first step would look like. That would be the composition function g of f of x. And now distributing the 3 in, that would give us 3x squared minus 3. Plus 3x squared plus 3. And then the minus 5 on the end, and when we combine like terms, 3x squared minus 2 for a final answer on that one.